Okay, now we're going to take a look at absolute value inequalities. So we have two categories here. We have when we're going to have absolute value of x is less than c or less than or equal to c. Where we have the other scenario where it's going to be greater than c or greater than or equal to c. So the first type here, we have an overlap. So we would have the solution of absolute value of x less than c or less than or equal to c would be where it's falling in between there. So we want to set up our scenarios as x is greater than or equal to negative c and x is less than c. This is just the n equals 2 version. I just want to make a note here. You could also just think of it this way. I tend to write this one first. So I would write if x is greater than c, then my other scenario is, less than c. My other scenario is going to be reverse the inequality, change the sign. So it would be greater than negative c. Likewise here, if I had just taking this one and putting it on the left, because that seems to be how I remember and work with it, even though the little scenario principle is written that way. And then I think, well, if this is one case, if I'm changing the sign to its opposite, I would have to reverse the inequality. Okay, so that's how we set those up. The other type is much easier. It's just opposite ways. We have the solutions of absolute value of x is greater than c or greater than or equal to c. So again, we have this or scenario, which is a union. And it's the same kind of setup, except instead of the word and, you have or. And this one's already in the order how I usually do it. So now we're going to look at an example, so hopefully that'll make a little more sense, and then we'll look at the graph and see how they compare. So for example 1, we have absolute value of x minus 2 less than 6. My absolute value is already isolated, so I can just write down my scenarios, which I'm going to take from up here, because it is a less than one situation. Okay, so if it's a less than situation, it's going to be an and. Okay, so I'm going to have x minus 2. It's not just x. Here it says x, but that means the absolute value expression. And that's going to be less than 6 is one case. But then I have to look at the other side of it. So when I change the sign, it's kind of like the same thing you were doing when you were doing equalities, but we have to make sure we put the word and. So that's different. And we also have to make sure when we're changing this sign here to negative 6, that's like multiplying by a negative 1. So we have to change our direction of our symbol. Okay, anytime we switch sides or change the sign of something by multiplying or dividing, we need to reverse the inequality symbol. So now we're just going to go ahead and solve this out. So we would have x is less than 8, and, or intersect, you could use that symbol, which is this. We would have x is greater than negative 4. Okay, so to write that in our set notation, it's a little trickier. I'm going to draw a graph up here to represent. So if I have 8 there and negative 4 is probably somewhere down here, I have everything has to be bigger than negative 4, but it is smaller than 8. So I have an open circle there. And what I want to include is my overlap here. So in my answer, I want things in between that. And you had some lessons on inequalities earlier. So for set notation, we would write it as, we could put the braces and stuff, but don't necessarily need to. All x such that we are going to have negative 4 less than x less than 8. You could write that as 2 separate pieces and just use the word and, just like here, would be okay too. For interval, you would write it like this. It's going to be curved because it's not including, not equal to, negative 4 up through 8. Okay, so that is how I would write my answer. Now, to graph it in Desmos, I'm going to flip over to that page to just show you how that would be set up and how we interpret that. So here's my graph. I plugged in y equals 6. That's the line, the horizontal line going across where y is 6. And then I have my absolute value of x minus 2 plotted here. So then I want to look at when my x minus 2 is less than 6. So I'm going to be looking in this area here. I don't know if you could see my cursor, but we would have anywhere from when x is negative 4 up through 8. So that you can tell what if your answer is correct by that. Now this next problem, we have a greater than or equal to, so this is going to be an or situation. So if you are taking a quiz or a test on this, I would have this sheet handy, or when you're doing your homework. It's a little hard to remember, but just, you can kind of make yourself just a little cheat sheet, the less than is and, greater than is or situation. So that's really the big difference. So the absolute value is already isolated, so we would just write it as 2x plus 1 is greater than or equal to 7, or 2x plus 1 is less than or equal to negative 7. Just remember, when you change the sign, you have to flip it. That's why I tend to write the positive version first, just easier to remember, because that's kind of how it lays out, and then I know I have to switch it, and I reverse my symbol. Then now I go ahead and solve. So here I'm going to have 2x greater than or equal to 6, so x is greater than or equal to 3, or 2x less than or equal to negative 8, so x is less than or equal to 8. So if you're thinking of the graph for this one, we would have opposite directions. So say I have the 3 here and the 8 is up here. This one tells me x has to be bigger than 3. Okay. And go ahead up there, and I just noticed I spaced out here and I have to fix my answer. So I don't know why I wrote that, but we would have x is less than or equal to negative 4 is the other one. So we're actually going to have negative 4 would be somewhere down here, and we would include the dot, and we have everything to the left of that. Okay, so those are my two scenarios. So in set notation, I would want to write it just as it kind of lays out there. X is less than or equal to negative 4 union, or x is greater than or equal to 3. An interval notation, we would write it as negative infinity up through 4 union, starting back up at, negative 4. I just don't like that number today, I guess. And then include the bracket, include the 3, comma, positive infinity. Okay, so this is interval notation. So in your electronic MyOpenMath, they might ask for a specific way to enter it, so that's why I'm showing you both. If I want a specific one, I will ask for that on a quiz or a test. But the examples, I think probably, I mean, we're varying here, giving you both. Doesn't usually matter. I'm not sure about the homework. I'm not sure you're going to have much paper homework on this. I think it'll just be electronic. But if you want more practice, let me know. We really, again, don't go into huge amount of detail with it. We do want to look at the graphs though, so I'm going to make the graph and just show you that in Desmos. Again, really quick, you can just get rid of your old one, and remember you're going to put in the y equals and then your absolute value symbol, and then we have 2x plus 1. Enter. Oh, it did add my symbol in for me. I didn't have to close it off. That's nice to know. A little new to Desmos myself. And then I want to know when that is actually greater than or equal to 7, but I'm just going to put in equal to 7 here. And I can look at it myself, and I can see where it's bigger. It's above that line. That's why there's 2 separate pieces. That's why I have that or situation for when I have a greater than, because I'm going to have these, tips sticking off to the left and the right above that horizontal line, where the other scenario is it's in between. So you can kind of remember it that way. So if it's lower, you're going to be at the bottom of the V where it's in together. So I hope that helps you kind of get the gist of how these work. Then we have just one more for you to try, and you can graph it and see how it comes out on your own. So pause the video and try this. Just a tip to get started. You're going to, again, you have to isolate the absolute value first. Okay, just like normal. And then remember, this is a less than situation, so it's that, it's going to be the bottom part of the V that you want, right? So you're doing an and because you want the overlap. If you're looking at a greater than, you're looking at the separated ors, right? So this one's going to be an and. And then you can just follow. It's just like number 1, so you can look back at that example to help you. So here's the answer for that. You should get from -3/2, including that, so a squared off bracket, or include the equal symbol, up to including 3/2. So that's your answer for number 3. I'll show you the graph with that one also. So I just figured out a fun thing in Desmos. You can actually shade in if you just use the less than or equal symbol here for the value that it's on the right hand side, that constant. It'll shade all that in for you, so you can clearly note that you have this -3/2 right here on the left, up through +3/2, and that will be your interval of x values, or your domain where that is true. I hope you found that helpful. Thanks for watching, and have an awesome day.